In this video we have another free response question related to related rates. And we have shown in the figure above water draining from a conical tank with a height of 12 and a diameter of 8 feet into a cylindrical tank that has a base with area 400 pi square feet. The depth h in feet of the water in the conical tank is changing at the rate of h minus 12 feet per minute. And so I'm going to write down dh dt is equal to h minus 12. So again, with these conical problems here, we're quite often going to use a system of similar triangles to reduce one of the variables. Now the first thing that we're asked for here is to write an expression for the volume of water in the conical tank as a function of h. And if we use the system of similar triangles here, showing half of a cross section of the conical tank, since the diameter is 8, the radius would be 4, and the height would be 12. For the smaller triangle, that would be r and h as its height. So we can use that to say that 4 is to 12 as r is to h. We want to solve for r in terms of h so that we can write an expression for the volume of water in the tank as a function of h. So we can simplify the 4 over 12 to 1/3, and so we get that h is equal to 3r. But that's not what we're looking for. We want to solve for r in terms of h. r is 1/3 h. And now we're ready to begin. If v is equal to 1/3 pi r squared h, but r is 1/3 h, so we want to remember to square 1/3 h times h, and that's going to give pi over 3 times 1/9 h squared h, or pi over 27 h cubed. And that does it for part A. Part B, we want to find out at what rate is the volume of water in the conical tank changing when h is equal to 3. So for this we're going to need dv dt, and we're going to simply of the last simplification of v being pi over 27 h cubed, we're going to take the derivative of that with respect to t, and that's going to give us 3 pi over 27 h squared dh dt, and we know what dh dt is. We have that written over there. That's h minus 12. And we want to solve this when h is equal to 3. And so we have 3 pi over 27 times 3 squared times 3 minus 12, which would be -9. And so we're going to get, might be simpler to use the 3 from the 3 pi and the 9 from the 3 squared to give you 27 to cancel with the denominator, and that would leave us with -9 pi cubic feet per minute, and so that would be our answer for part B. Finally, for part C, if we let y be the depth in feet of water in the cylindrical tank, then at what rate is y changing when h is equal to 3? Well, we're told earlier that the cylindrical tank has a base with area 400 pi square feet. And since volume is just the area of the base times the height, then volume would be 400 pi times h. Sorry, that would be times y, because we're working with the cylindrical tank right now. We want to take the derivative of both sides with respect to t. We'd get dv dt is equal to 400 pi dy dt. Now, an important thing here is that the water is changing in the cylindrical tank at the opposite rate that it's changing in the conical tank. It's decreasing from the conical tank, but it's increasing into the cylindrical tank. So dv dt is just 9 pi, and that's equal to 400 pi dy dt, and we're trying to solve for dy dt. So we divide both sides by 400 pi, and we end up with dy dt is 9 over 400 feet cubed per minute. And that's our answer for part C. And that does it for this problem.